Today we're going to be doing the naming ionic and covalent compounds lab. I'm going to get you started doing some practice problems with you. You are going to need your periodic table out for this because for the ionic compounds, you do have to remember that if there's only one oxidation state present, then you do not need to include a Roman numeral in the name. And if there's multiple oxidation states, like a lot of the transition metals tend to have, like these guys here, you are going to need to include a Roman numeral. That doesn't apply to covalent, but you're still going to want your periodic table out. So to do a couple problems, it's going to be pretty simple. So for this first one, NaCl, elements involved, metal, non-metal, that makes it ionic. And then for the naming, the metal name doesn't change. Na is just called sodium. And then the non-metal name is, it gets an IDE ending, so chlorine becomes chloride. Now, the reason I didn't include a Roman numeral is because sodium has only one oxidation state. If I were to do an element that does have more than one oxidation state, like chromium, so if we jump down to this one, it's still metal, non-metal, ionic, Cr is called chromium, oxygen gets the IDE ending, but because Cr has more than one oxidation state, we then have to figure out what the oxidation state is. So for this, I have to use my rules. So the rule for O, and it's in a compound, it's -2. This compound does not have a charge, so I'm going to set it equal to 0. And the way I like to say it is you multiply down, you add across. So -2 times the unwritten 1 gives me -2 from oxygen. Therefore, I'm going to need +2 from Cr. So it's going to have to be the entire plus 2. Now, some people would say, then why is the formula 1 Cr and 1 O and not 2 and 2? That's because with the crisscross method, we reduce and then crisscross. But that does not mean that when we name it, its oxidation state is really 1. And the oxidation states aren't actually 1 and 1. They are really 2 and 2. So when we give it the Roman numeral, it gets the Roman numeral 2, even though we reduced it in the crisscross. So don't confuse that. To go backwards, just to do 1 or 2 like that, like for example, calcium nitride. This is going to be a metal with a non-metal. What you need to do is you need to look up the oxidation state. So calcium on the periodic table is +2. Nitrogen, which would be nitride, is -3. That's the first oxidation state. That's the one we're going to use all the time. They can't be reduced, so we crisscross them. And then our formula is going to be Ca3N2. So that's pretty much what you're going to be doing for this whole first page. A little hint for the people who are watching the video, the entire first page is ionic. So they're all going to be metal, non-metal. They're all going to be ionic. Now, when we get to the back page, these guys are going to be even easier. They are, of the first page at least, they are all covalent. So I'm going to do one or two. So for these are all going to be multiple nonmetals, and they are covalent. So for them, remember, we use a different set of rules. We have to say how many there are. So I'm going to make the mistake of saying mono hydrogen. So we just add a prefix to the first part of the name, and then the second part, or the last name, gets the IDE ending. So again, there's a mistake here. The rule is you can never start with mono. I'll cross it out in red. So the name for this is just going to be hydrogen monochloride. Okay, that's it. If we wanted to do another one, this one would be, for the same reason, nitrogen Tri Hydride. Now I wanted to to mention these because here I have the hydrogen and it doesn't get an IDE ending, but in the second one it does get an IDE ending, and that's because of the way it's written. If the hydrogen is the last name, then it gets an IDE ending. If the hydrogen is the first part of the element, then it does not get the IDE ending. So, and again, we're going to get some flexibility on this because if you wrote it H3N, then it would be trihydrogen nitride. If you wrote it NH3, technically it would be nitrogen trihydride. We never include the mono. Well, actually, if you flipped it, it would be trihydrogen mononitride. I'm not going to worry about that. You'll never get a question. On the Regents, they're not going to care. They're going to present it as a compound, and they're going to say, name this, and you're just going to use their rules. If they give you a name, like some of these, it's pretty easy. Like, for example, let's do one. Let's do the one all the way at the bottom. Tricarbon tetranitride. Well, tri tells me I have 3 carbons. Tetra tells me I have 4 nitrogens. So it's just going to be C3N4. Done. That's it. For another one, just do one more. Phosphorus trihydride. Well, the fact that they didn't write anything means that there's the unwritten crossed out mono there. So that's just going to be 1P, and then trihydride means 3 H's. So covalent are honestly a lot easier to name, but this entire page is going to be covalent. When we get to the next page, it's going to look like this. This is going to be a mix of ionic and covalent. So you're gonna want to have your rules out, your naming flow chart. You're gonna want to have that out especially for these. And I would make sure you do the elements and the type of bond first, because you need to know this information first. And then once you know this information, you can then figure out, all right, covalent get named one way, ionic get named another. But if you don't know the difference, you're not going to be able to figure it out. So be aware of that, and be careful with some of these. Like, I'll put these in parentheses. These are polyatomic ions found on table E. So they're your polyatomic ion table. The names, you get them right off here. You can't change the name at all. You can't change the ending. You can't do anything to it. So like, for example, Cr2O7 is called dichromate. I don't care if it's the second part of the name. You don't get to put an IDE ending on this and change it. These names are predetermined. You can't mess with them. You can't do anything with them. So that is going to be the entire second page, both the front and the back, more of the same. They are a mix of ionic and covalent. So be aware of that. And good luck with the lab. We'll go over it in class.